next 15 minutes, we are going to show you that machine which has never been fooled.
Hi, this is Soumodeep Mete.
This is Banisa, Pramanick.
This is Shruti, Saha.
This is Rupak, Maiti.
We are from the Department of Electronics and Communication of TMSL batch 2026.
Every vote in India is protected by machines that eliminate ballot stuffing and cut counting time from days to hours. But there's one part of the process that still runs exactly the way it did 50 years ago. A tired human officer glancing at your face and comparing it to a photo ID. That single glance is the weakest link in the world's largest democracy.
We have spent this year building a voting machine where that human judgment call simply does not exist anymore. Not because we trust officers less, but because we build a system that never needs to ask them to make that call at all.
In the next 15 minutes, we are going to show you that machine which has never been fooled, but not once, in 32 live fraud attempts, and we are going to show you exactly how live right now.
Here is the uncomfortable engineering truth. The standard fix and the industry reaches for is a fingerprint scanner bolted into the existing EVM. Sounds solid until you remember who is the actually voting.
So, what does every single one of these systems do when the fingerprint fails? They add an officer override button, and the second that the button exists, you are back to the square one. A corrupt or coerced officer can press it for anyone. The whole biometric security promise collapses into a single point of human trust.
And this is not hypothetical. In January 2024, the Supreme Court of India ruled that ballot paper in Chandigarh mayor election had been deliberately defaced by a returning officer. The court called it, in its own word, a murder of democracy.
So the real question we asked ourselves wasn't how do we add one more biometric layer? It was how do we build a system where no single point, human or technical, can ever unlock a fraud vote alone.
Meet the trifactor biometric EVM. 3 independent sequential check. Defect 1, you still face the other. No override exit anywhere in the system, not in the firmware, not in the software, not as a hidden admin backdoor.
Hold up, let's get back into the control unit. So, factor 1 suggests fingerprint scan at officer's desk on an R307S optical sensor matched against a local SQLite database. Zero interest and zero cloud.
So the factor 2, and this is the one nobody else has ever combined properly, passive liveness detection. Our webcam watches for a real human blink measured through something called eye aspect ratio across a media pipe 468-point facial mesh. A printed photo cannot blink. Phone screen replay cannot blink enough to fool this. Only then does the FaceNet 512 deep learning model, the same architecture Google uses for clustering the face of photos, generating 512 dimensional face signature and match it with the enrolled voter.
Factor 3. The voter scan their fingerprint a second time inside a private booth on a completely separate Arduino. They seal the vote against substitution. The person who authenticated a desk is guaranteed to the person casting the vote inside.
I split it this way because the Election Commission own design principle says the identity verification unit and the vote casting unit must physically isolate. Even if someone fully compromises our control unit software, they cannot switch the system into enrollment mode or touch a cast vote. That decision lives on hardware they cannot reach without physically opening the shielded boot unit.
So, and the whole thing's boot itself. No laptop, no technician, no terminal command on election morning. Power on, and within about 30 seconds the system is live and waiting for the first voter.
Let's start with the working principle of the project which we have made. So at first, this is our control unit. Considering Rupak as the admin, the polling officer, and Banisa Pramanick as a voter. So this is the pre-voting era where the admin will give his fingerprint to get the access. Then he will enroll a new voter. We can enroll as many voters as we want, but for now we will only show as a one voter as an example. So let's start with the working. So first the admin will give his access to the admin. Give your fingerprint. The admin button is clicked, the fingerprint is given, the screen shows the biometric is being checked. The face where the live detection happened, the blinking which actually shows the this is the live photo, it's not a picture or anything, it's a live human who is doing the access. Now we go with the enrollment. Now the enrollment mode here in the screen it displays. So first we will know what's your photo ID, Manisha?
7.
So 7 is her voter ID. So the 7 has been clicked by the admin. The face has been detected in the camera. Look straight, Manisha. Here in the
Turn left.
screen is actually showing you all the instructions which the voter have to do. Turn left.
Turn right.
This is done to get the capture of the 360 face
Okay.
of the voter. So the capturing is done.
Blink.
Unique face. The blinking which actually shows you
Blink.
that it's a live photo. It's not
Blink.
any photo of a person.
Right hand or left hand?
Left hand.
Left hand.
Put your finger.
Thumb.
Thumb.
Remove your finger. Same angle. Okay.
So by different faces, the fingerprint have been captured. The fingerprint have been done. Here on the screen is actually showing the fingerprint is being done. And the face structure is also being taken. This is how the enrollment of the voter being done by the polling officer. Now we are moving to the voting era. Here again the same process will be run where the polling officer will put his finger into the fingerprint sensor, get the access of the admin. So I will request Rupak to do it. First, he will click on it, B button, fingerprint, access is been trying. Yes, fingerprint match, camera, check. Analyzing done. Hold.
Identity fraud.
Yeah. See, here it's actually the enrollment fraud which has been shown. This is actually shown because Banisa have came into the screen of the camera and here the fraud that occurred because the sensor is actually getting his face and not the polling officer's face. So again we will retry the same thing and here I will request Banisa, please move forward like a side. Yeah. Now again the same thing he will do. The admin access has been taken, fingerprint sensor, fingerprint match, biometric checking will be done. Analyzing the face. Hold steady. These all the instructions are actually showing on the screen. Transfer OK and here see the data is being transferred to the ballot unit. So as Manisha moved, the face actually detect his face and the errors which will actually we can overcome because nobody can else could access to the ballot unit or the control unit other than the polling officer because the face data was already being given to it. So this sensing part is not only applicable for the polling officer but it's also applicable for any voter. No voter's face or fingerprint could not be done by any other voter. Then also it will show the same error. If in case of voter 1, here in our case Banisa considering as a voter 1, if anyone comes in place of her then same error will be shown and the camera as well as the fingerprint will not take that data. So now we'll go with the voting process. So the voter 1, Banisa, please come and take your seat. So the first data which is an unique value that is a voting ID. Every voter will have their own unique ID. So Banisa, what's your voter ID?
7.
7. So here the polling officer put in it. Anyone, any voter also himself or herself could put that data.
Left thumb.
Now voter ID will put, fingerprint will
Match.
given, matched.
Here.
The data has been moved here.
Hold.
Place your finger.
Place your finger. Okay. Now blink here.
Now liveliness detection is being done here. Blink, Banisa. Hold your face steady.
Okay. Vote.
Now she can vote.
Vote.
Here. Here's the two set.
Here you can vote down.
So the voting. So the voting process has been done. The point which I have to raise is that here first the voter have put her finger and that data moved to the ballot unit. Ballot unit does not contain any data previously. It takes the data from the control unit. It's actually for the re-verification. It's to see that the same person or the same voter is actually voting. After verification, it's the actual person that's going to vote. So first, Banisa put her finger into the sensor. That data moved to the ballot unit. When before putting the vote, again the re-verification been done, looking that this is the same person who have came to vote. So after putting her finger, the liveliness has been checked on the camera. It's to see that no other photos or videos have came or any other person it has been came. It's the actual person, real one who have came to vote. After the re-verification, she put her vote whatever according to her choice, and to lock that vote again she have to put that fingerprint. This is how the full proper vote has been locked and has been done. This is the whole process of the voting. It contains a lot of verifications to remove any type of redundancy and duplicacy, and this is how our trifactor biometric EVM works. Thank you.